Dear learners, welcome to the course Disaster Management Strategies. As you know, Model 10, entitled Environment and Disaster Risk Reductions, consists of 4 units. The third unit of the Model 10 is Unit 18, Climate Change and Disaster. Today, we will explore this unit together. I am Utpal Lekha, your course coordinator from Krishnakanta Handike State Open University. I am excited to have you with me on this journey. Let's get started. Our planet is warming at an unprecedented rate. Glaciers are melting, sea levels are rising, extreme weather events are becoming more frequent and intense, and ecosystems are shifting in ways that threaten human societies. These changes are not isolated incidents, they are symptoms of climate change, driven primarily by human activities since the Industrial Revolutions. Climate change is a global challenge that affects every country and every person, from rising sea levels threatening coastal communities in small island nations to prolonged droughts impacting farmers in sub Saharan Africa and stronger hurricanes battering the Caribbean and Gulf Coast. It amplifies existing hazards and creates new ones, turning manageable risks into devastating disasters. This unit explores climate change from a disaster risk reduction perspective. Healthy ecosystems such as forests, wetlands, mangroves, and grasslands act as natural buffers against hazards like floods, storms, and droughts. Climate change weakens this buffer, making communities more vulnerable. By understanding the history, science, effects, and management strategies of climate change, you will see how individual and collective actions, from reducing emissions to restoring nature, can build resilience and protect lives worldwide. History of climate change awareness. Modern understanding of climate change and sustainability did not appear suddenly. It developed step by step through scientific discoveries, environmental disasters, and global meetings. Key milestones include: in 1971, American biologist Barry Commoner published the book The Closing Circle. He introduced the idea of sustainability and gave 4 famous laws of ecology. First, everything is connected to everything else. Second, everything must go somewhere, implies there is no away for waste in nature. Third, nature knows best, implies human interventions often carry irreversible risk. Fourth, there is no such thing as free lunch, implies every action or benefit we gain from nature has a hidden cost. In 1972, the United Nations held the Stockholm Conference, the first global environmental meeting, and created the United Nations Environmental Programme, that is UNEP, and established June 5 as World Environment Day. In 1985, scientists discovered the ozone hole over Antarctica and began warning about climate change. In 1987, the Brundtland Commission's report, Our Common Future, came out, defines sustainable development as development that meets the needs of the present without compromising the ability of future generations to meet their own needs. In 1992, Earth Summit held in Rio de Janeiro led to major agreements on climate, biodiversity, and sustainable development. In 2015, 2 landmark events, the Paris Agreement, that is COP21, where 195 countries agreed to limit global warming to well below 2 degree, preferably 1.5 degrees centigrade, and reach net zero emissions by around 2050. Adoptions of the 70 sustainable goals, that is SDGs, including Sustainable Goal 13, which is totally related with climate actions. Recent development as of 2025. June 12, 2025, the World Health Organizations declared climate change as, June 12, 2025, the World Health Organizations declared climate change a public health emergency, linking it to food, water shortage, disease spread, and intensified disasters. In January 2025, the United States, a country of 350 million people, contribute 26.5% of global GDP and contributed significantly to World Health Organization funding in past, announced withdrawal from the WHO effective from 2026 and the Paris Agreement. These events underscore how geopolitical decisions can slow global cooperations. The largest current CO2 emitters are China, USA, India, Russia, and Japan, while the USA remains the largest historical emitters according to Global Carbon Atlas. Meaning and science of climate change. Climate change means long-term change in temperature, rainfall, wind pattern, and other aspects of Earth's climate. It is mainly caused by human activities that increases greenhouse gases in the atmosphere. The greenhouse effect is natural and necessary as sunlight warms the earth. Some heat is trapped by gas like carbon dioxide, methane, nitrous oxide, and fluorinated gases. This keeps earth warm enough for life. Human activities release too much of these greenhouse gases into the atmosphere. As a result, extra heat gets trapped near the Earth's surface, causing global warming, which in turn drives and intensifies climate change. The Intergovernmental Panel on Climate Change, that is IPCC, states that more than 90% of warming since the mid-20th century is human caused. Major greenhouse gases and their shares in the greenhouse effect are carbon dioxide, contribute 60 to 65% to the greenhouse effect. It produced mainly by burning fossil fuels, coal, oil, petrol, deforestation, cement productions. Methane contributes 15 to 20% to the greenhouse effect. It is produced mainly by livestock, rice fields, landfills, natural gas leaks, etc. Nitrous oxide contributes 5 to 6% to the greenhouse effect. It is produced mainly by fertilizers and industrial processes. Fluorinated gases contributes 1 to 2% to the greenhouse effect. It is produced mainly by synthetic chemicals used in refrigeration and air conditioning. Water vapor contributes 10 to 15% to the greenhouse effect. It is naturally present in the atmosphere but increases with warming. Now we will discuss the CO2 trend. The Kelling curve, measured continuously since 1958 at the Mauna Loa Observatory in Hawaii, shows the steady rise in atmospheric carbon dioxide levels. This represents a roughly 50% increase in less than 200 years, a rate of rise far faster than any natural fluctuations recording in Earth's history. The largest current emitters of CO2 are China, USA, India, Russia, and Japan, while the United States remain the single largest historical emitter of greenhouse gases when measured cumulatively since the start of the Industrial Revolution in 1850. Drivers of climate change. Here we will discuss 4 core drivers of climate change. First, primary human drivers of modern climate change. Globalization as drivers of climate change. Then north-south divide as drivers of climate change, and lastly ecological footprint as drivers of climate change. Let us start with primary human drivers of modern climate change. The primary cause of modern climate change is human activities, especially since the Industrial Revolution starting around 1750, which dramatically increased greenhouse gases emissions. The main drivers are burning fossil fuel. Coal, oil, and natural gas are burned for electric generations or electricity generations, transportations, heating, and industrial processes. This releases huge amount of carbon dioxide and the single largest contributor to global warming. Deforestation and land use change. Cutting down forest for agriculture, timber, mining, or urban development removes trees that naturally absorb CO2. When forests are cleared or burned, stored carbon is released back into the atmosphere, and the land loses its ability to take up more CO2. Industrial processes. Manufacturing cement, steel, chemicals, and other materials releases CO2 and other greenhouse gases through chemical reactions. Agriculture and livestock. Farming practices releases methane from the rice paddies and livestock digestion, nitrous oxide from fertilizers and manure, and carbon dioxide from machinery and land cleaning. Human societies' heavy dependence on fossil fuels, together with widespread deforestation and intensified agriculture, and industry has overloaded the atmosphere with excess greenhouse gases. This traps more heat near Earth's surface, driving rapid global warming and accelerating climate change. Globalization as drivers of climate change. Globalization has significantly accelerated greenhouse gas emissions through the worldwide expansion of trade, capital flows, and capitalist development, dramatically increasing energy demand, industrial productions, transportation, and large-scale resource extraction. It has unfolded in two major epochs. The first from 1860 to 1914, an imperialist colonial phase driven by reduced transportation cost via steamship and railways, which enabled massive resource explorations and global trade networks, and a modern phase since 1980, propelled by advances in information and communication technology and rapid capital mobility, which have intensified global supply chains, reallocated manufacturing to lower cost regions, and boosted consumer consumption worldwide. Developed countries of the global north, such as USA, Germany, Japan, and Western Europe, have historically driven and benefited most from globalizations, dominating multinational corporations, financial systems, and high-value industries, while shifting resources intensive and polluting activities to global south. This has effectively exported emissions and environmental costs to developing nations, allowing the north to maintain economic advantages even as it reduces domestic emission in some sectors. North-South divide as drivers of climate change. The North-South divide further deepens this inequality. The global North enjoys high GDP, advanced technology, and industrializations, but carries the largest historical responsibility for emissions due to early industrializations and high per capita consumptions. In contrast, the global South, for example, countries like Nigeria, Bangladesh, India, and many in Africa and Latin America, has lower GDP, greater reliance on agriculture and raw material exports, and faces disproportionate climate impacts despite much lower per capita emissions. The root of this divide lie in colonialism, unequal trade structure, and historical resource exploitations, which continue today through debt traps, industrial waste dumping in South, and limited access to clean technology. This unequal pattern highlights a profound climate injustice. Those who have contributed least to the problem suffer the most severe consequences, while the primary historical emitters continue to benefit from the global economic system they help shape. Ecological footprints as drivers of climate change. The ecological footprints measures how much of Earth's biological productive land and sea area humanity demands each year to produce the resource we consume and absorb our waste, especially CO2 emissions. It compares human demand against nature's renewable supply, that is biocapacity. Currently, global demand already exceeds one planet's capacity by about 50 to 70%, creating an overshot. Projections show that if current consumption patterns continue by 2050, humanity would need the equivalent of 2 Earths, and by 2100, 4 Earths, severely threatening long-term sustainability, depleting natural resources, accelerating biodiversity loss, worsening climate change, and increasing the risks of ecological collapse and intensified disasters. Effects of climate change. Climate change affects everything like environment, economy, society, and politics. Climate change is a threat multiplier that disrupts natural systems, weakens economies, divides societies, and challenges government worldwide. It does not act alone. It amplifies existing problems like poverty and inequality, making disasters more frequent, severe, and costly. Environmental effect of climate change. Higher temperature cause faster evaporations, leading to heavier rainstorm and long droughts. Warmer air can hold more moisture, so when storms form, they often dump huge amount of rain very quickly, causing flash floods. In contrast, in dry regions, first evaporations dries out soils, rivers, and reservoirs much quicker, creating prolonged drought that kills crops, dry up water sources, and harm wildlife. Extreme weather events are becoming more intense and frequent. Warmer oceans provide more energy to cyclones, making them stronger and more. Heat waves last longer and reach deadly levels. Floods become deeper and more widespread, while saturated hillsides trigger more frequent and dangerous landslides. Sea level rise from melting glaciers and ice sheets threatens coastal areas and islands. Polar ice caps and mountain glaciers are melting faster, raising global sea levels by about 20 centimeters since 1900, with projections of 0 to 3 to 1 meter by 2100. These flood low-lying deltas allows saltwater to invade freshwater resources and put millions at risk of displacement in cities like Kolkata, Mumbai, Chennai, Dhaka, and low-lying island nations such as the Maldives. Changes in the jet stream create unpredictable and extreme weather patterns. Warming in the Arctic weakens the jet stream, that is, fast moving high altitude winds, causing it to wobble or meander. This leads to unusual weather, record cold snap in one region while another area experiences extreme heat. Shifts in seasons disrupt natural and agricultural cycles. Warmer conditions cause spring to arrive 2-3 weeks earlier in many places, while monsoon may start later or become erratic. Crops and wild plants flower or ripen at the wrong time, leading to poor fruit quality, reduced harvest, and disrupted food chains. Ecosystems are disrupted, causing species to move, disappear, or face extinction. Habitat shifts towards the poles or higher altitude as species try to follow suitable climates. Up to 1 million species are at risk of extinction. Coral reefs suffer mass bleaching and die off from warmer oceans. Some forests dry out and transitions into grasslands or savannas, reducing their ability to store carbon and support diverse food webs. Ecosystem effects of climate change. Climate change creates major economic challenges by damaging agriculture, infrastructure, water supply, and resource availability. These impacts hit developing regions hardest, increase cost, and threaten food security, job, and growth. Agriculture suffer from unreliable weather, leading to lower crop yield and higher food prices. Fewer predictable rainy days, more pest attacks, drying soils, and sudden heavy floods reduce production of key crops like rice, wheat, and pulses. Infrastructure faces repeated destructions from extreme weather, leading to massive repair costs. Roads, bridges, house, power lines, and ports are frequently damaged or washed away by floods and cyclones. Global economic losses from climate-related disasters already reach about $1.5 trillion per year. Water scarcity becomes widespread as river and groundwater sources dry up. Changing rainfall patterns and shrinking glaciers reduce river flows by 20 to 30% in major systems like the Ganga and Brahmaputra. By 2050, up to 2.4 billion people worldwide could face severe water shortage, affecting drinking water, irrigations for farming, hydropower generations, and industries. Resource conflicts increase due to growing competitions over land, water, and energy. As fertile land, fresh water, and available energy become scarcer, tension rise both locally and internationally. Example includes disputes over the Nile River waters, India-Pakistan tension over shared river, and rising energy prices as countries struggle to shift from fossil fuels to renewable quickly enough. Social effects of climate change. Climate change creates deep social changes by displacing people, harming health, and hitting the poorest and most vulnerable groups hardest. These impacts worsen existing inequalities and make recovery from disasters much more difficult for millions. Climate refugees. Millions are forced to leave their homes. Rising sea levels, repeated floods, and prolonged droughts make interior areas unlivable. Globally, around 21 million people are displaced every year due to climate related disasters. More frequent and intense heat waves cause heat strokes and health related deaths. Warmer temperatures allow mosquitoes to survive in new places, spreading disease like malaria and dengue into higher altitudes. Poor and marginalized communities suffer the most. Lower income groups, women, children, small farmers, fisherfolk, and tribal and indigenous populations are hit hardest because they have the fewer resources to prepare or recover. They often lack insurance, early warning systems, or safe places to go during disasters. Political effects of climate change. Climate change is increasingly shaping politics at local, national, and global levels. It creates new tensions, forces policy changes, and tests international cooperations. More international tensions over scarce resources and migrations. Competitions for limited water, fertile land, and energy sparks dispute between countries as already discussed. Growing pressures to shift to renewable energy and reduce emissions. Rising climate impacts push governments and citizens to demand faster transitions away from fossil fuels. Public protest, youth movements, for example, Friday for Future, and new policies drive ambitious targets such as the European Union's Green Deal aiming for the net zero by 2050 or India's goal of 500 GW of renewable energy capacity by 2030. At the same time, powerful fossil fuel industries and lobbies resistance, creating political battles over subsidies, regulations, and energy prices. Urgent need for stronger global agreements, but progress is uneven. International frameworks like the Paris Agreement, Sustainable Development Goals, and Sendai frameworks for disaster risk reductions are essential for coordinated actions. However, setbacks such as the United States temporarily withdrawing from the Paris Agreement or weakening commitments erode global trust. In short, climate change is not just an environmental issue, it is becoming a major political challenge. It heightens conflicts over resources and borders, forces government to rethink energy and development policies, and test whether the world can cooperate effectively or allow divisions to deepen. Strong leadership, fair finance, and inclusive agreements are critical to managing these political pressures and protecting vulnerable communities. Now we'll discuss climate change and disaster risk reductions. Climate change acts as a threat multiplier. It does not create new types of disaster on its own, but it makes existing hazard more frequent, intense, and destructive, while also making communities less able to cope. It intensified hazards. Warmer oceans provide more energy to cyclones, making them stronger with higher wind speed and heavier, more concentrated rainfall. Events cause flash floods and river overflows, especially in monsoon. It reduces ecosystem resilience. Healthy ecosystem acts as a natural shield, such as wetlands absorb excess floodwater, mangrove forests break storm surges, forest stabilizes slopes against landslides. Climate change degrades these buffers, leaving landscape more exposed to hazard. It increases vulnerability. Poor and marginalized communities often live in high-risk areas with limited access to early warning, insurance, safe housing, or savings. Effective disaster risk reductions in the age of climate change requires integrating climate considerations into every step, like first, early warning system, second, resilience infrastructure, third, ecosystem restoration, and fourth, community preparedness. Climate change does not just make disaster bigger, it makes them harder to prevent and recover from. By combining traditional disaster risk reductions with climate smart actions such as ecosystem protections, resilient crops, clean energy, we can reduce risks and build safer communities even as the climate continues to change. Community level strategies for climate management and resilience. Sustainable agriculture. Sustainable agriculture involves shifting to climate smart farming practices like drought resistant crop varieties, adopt agroforestry to improve soil health and provide shade, reduce reliance on chemical fertilizers and pesticides, etc. Ecosystem restoration. Ecosystem restoration focuses on reforestation by planting native trees on degraded land and protecting or restoring wetlands and mangroves. Water management. Water management includes rainwater harvesting to collect and store rainfall, construction of small check dams or ponds to slow runoff, and restorations of wetlands and rivers to store water during heavy rains, and research underground water supplies for use during dry seasons. Renewable energy. Renewable energy adoptions entails installing solar panels for household and community electricity needs or implementing small-scale micro hydropower systems in hilly or riverine areas. Community education and preparedness. Community educations and preparedness programs train farmers in resilient farming techniques, establishing early warning systems for flood and cyclones, and organize regular disaster drills. Schools, women's group, and youth are actively involved to spread awareness, build local knowledge, and develop leadership for long-term resilience. Policy advocacy. Policy advocacy encourages communities to demand equitable climate finance from high-emitting countries in the global north to support vulnerable regions, while pushing for stronger local environmental laws to protect forests, wetlands, rivers, and other critical ecosystems. Now we'll discuss climate management, that is mitigation, adaptations, and finance. Climate management involves coordinated global and local efforts to address climate change through two main strategies: mitigation, adaptations, and supported by climate finance. Mitigation implies reducing the greenhouse gas emissions to limiting future warming. The goal is to slow down or stop the rise in global temperature by cutting emissions at the source. Key actions include transitioning to renewable energy sources like solar, wind, and hydropower, replacing coal, oil, and gases. Improving energy efficiency in homes, industries, vehicles, and appliances, using less energy for the same work. Reforestation and afforestation by planting trees and restoring forests to absorb CO2 from the air. Promoting sustainable agriculture by reducing methane from livestock and rice fields, cutting nitrous oxide from fertilizers, and using low emissions farming methods. Implementing carbon pricing in terms of taxes or cap and trade systems, and carbon storage technologies to make polluting expensive and trap emissions. Adaptation help people, ecosystem, and infrastructure survive and thrive despite rising temperatures, extreme weather, and sea level rise. Key actions include constructing climate resilient infrastructure such as flood barriers, elevated roads, houses, drought resistant crop varieties, and strong coastal defenses. Developing early warning systems such as weather forecast, flood alerts, cyclone silence, and mobile apps to give communities time to prepare. Using ecosystem-based approaches such as restoring mangroves to break storm surges, protecting wetlands to store floodwater, and conserving forests to prevent landslides. Improving water management such as rainwater harvesting, small check dams, efficient irrigations, and restoring rivers, wetlands to ensure water supply during dry spells. Climate finance implies funding for mitigation and adaptations. Implementing these actions require huge investments. Climate finance is the money directed towards reducing emissions, that is mitigations, and preparing for impacts, that is adaptations. Total global climate finance. As of the most recent comprehensive data, that is from 2021 to 22, the world invests approximately US dollar 1.3 trillion per year in climate related activities. This funding is split very unevenly between two main goals. Mitigation finance accounts for approximately US dollar 1.2 trillion per year, representing 90 to 95% of the total global climate finance. This money goes towards reducing greenhouse gas emissions and slowing future warming. It is mostly private investment because projects like solar farm, wind power plants, and energy efficiency upgrades offer clear financial returns, profits from selling electricity or saving cost. Private companies and investors are thereof eager to fund these initiatives. Adaptation finance accounts for approximately US dollar 69 billion per year, representing 5 to 10% of the total global climate finance. This much smaller amount supports actions to help communities, ecosystems, and infrastructure cope with climate impacts that are already happening. For example, building flood barriers, developing drought-resistant crops, restoring wetlands. Almost all of it comes from public fundings. Governments, multilateral banks like the World Bank and international climate funds. Very little private money flow there because adaptation projects usually do not generate quick profits as they save lives and reduce losses but do not produce direct revenue like a power plant does. This imbalance is a major global concern. Mitigation attracts far more funding because it is more bankable, while adaptations, which is critical for protecting the poorest and most vulnerable people from floods, droughts, heat waves, and sea level rise, remain severely underfunded. Bridging this gap is essential for fair and effective climate action worldwide. It is important to highlight that developing countries will need approximately US dollar 212 billion per year by 2030 just to cover essential adaptation measures. Sources of climate adaptation finance. Public sources comprising 98% of adaptation funding, including multilateral development banks, World Bank, Asian Development Bank, etc. Bilateral aid from developed countries, for example, Germany, Japan, etc. Dedicated funds like Green Climate Fund, Adaptation Fund, Global Environmental Facility, etc. National budgets, for example, India allocates billions annually through debt servicing limit spending. Private sources comprising only 2% of adaptation funding, green bonds, that is debt instruments for eco projects, corporate investment, and insurance and risk transfer mechanism. Adaptation projects often have low or no quick financial returns. For example, building a flood wall saves lives but does not generate profit. So private investors prefer mitigations. Developing nations face heavy debt burdens, limiting their ability to borrow and or invest. Mitigation attracts money easily, but adaptation, which protects the poorest and most vulnerable, remains severely underfunded. This creates a dangerous funding gap. Mitigation stops the problem from getting worse. Adaptation helps us survive what's already here. Both need massive fair funding, especially adaptations for vulnerable regions like small island states, least developed countries, and flood-prone areas. Bridging the finance gap through stronger global cooperations, innovative funding tools, and prioritizing the most at-risk communities is essential for effective climate management and disaster resilience. With this, we conclude today's discussion. Thank you for your attention, and I look forward to continue our journey in the next sessions. Happy learning.